Hi, my name is Phil Bagg, and we're going to explore conditions that switch between actions in this video. If you haven't already watched conditions that start actions, I suggest you watch that video first. You can find more essential computing science knowledge videos at codit.co.uk/video. You are looking at a semantic wave, which is great for thinking about curriculum sequencing. The idea is to take a complex idea such as conditions that switch between actions and unpack the concept until we get to the most concrete examples and simplest meanings. Starting at the red arrow, you can see us doing that on the downward curve from left to right. What is a condition? What is selection? Conditions acting like a switch. At the bottom we have pupils acting out everyday algorithms. Then the curve to the right is when we repack meaning to get back to more complex understanding. Flow of control, concept in code, limited number of conditions in code. In the rest of the video we're going to impact this even more. If you have covered conditions that end loops previously, now is a great time to refresh pupils' memory, helping them to retrieve the condition part of that to help them with their new understanding. If you haven't covered this type of repetition, ignore this slide. If you have covered conditions that start actions previously, now is a great time to refresh pupils' memory, helping them to retrieve prior knowledge. If you haven't covered this type of conditional selection, I would recommend doing this before tackling conditions that switch between actions, as it's slightly easier. Before we can use a condition, we need to describe what a simple algorithmic condition is. Basically, it's any question that can be answered with either yes or no, true or false. It can help to check pupils' understanding of a simple condition with a simple question like this. We can then identify that C is not a good condition because we can't get to yes or no, true or false answer from it. It helps to identify the condition and the actions in the algorithm. The most important difference between a condition starts action and a condition that switches between actions is that conditions that are false lead to actions as well as conditions that are true. Conditions can be both true or false. They are either one or the other when they are checked. Just like a light, it is either on or off, true or false. I'm a big believer in finding everyday examples, but this is one of those cases where we can end up watering down the concept or adding misconceptions through everyday examples. The problem here is that many parents will mix the rewards and sanctions, whereas in algorithm or code, it is always either true or false. If you have introduced conditions that start actions first, you will have given basic everyday examples that don't introduce misconceptions. Pupils are no longer novices to the basic concept at this point, so cognitive load is less of an issue and you less need these sort of crutches to help them make early progress. Acting out everyday algorithms gives us a chance to assess pupils' initial understanding of the process. Will they bow and wave where only one of these is possible? Checking pupils' understanding of what parts of the algorithm are affected by the condition and what parts are not helps to determine who will need more support. Writing their own example gives you a chance to see who has understood the concept and who is able to adapt it and come up with their own examples. Some will make very minor adaptations and some will use it in a very different way. Here we've used dots to show actions and a decision diamond to represent our condition. We can then demonstrate how this works by talking through the actions while tracing the flow of control on the diagram, starting at the top, going down the orange path if the condition was true, and down the blue path if it was false, pointing out that bowing slowly will be triggered if the condition was true, and waving will be triggered if the condition is false. But of course, only one pathway can be followed. Once we have established the basics, we can then move on to look at the concept in whatever programming language we have chosen. Here we're using Scratch code. It also identifies conditions with an if. If you look carefully, code affected by the condition is indented. The flow of control helps to show pupils the two pathways and helps them develop a mental picture of what the code does within the machine. It also helps pupils to see the link between our everyday algorithm and a code example. Many of the best examples involve quizzes, although the condition is a more complex one that you might need to demonstrate and explain in a bit more detail. The flow of control works well for quiz examples too. Let's face it, you can only have a right or a wrong answer from a quiz, can't you? Earlier we talked about conditions being questions we could answer yes or no, true or false to. Here we are further refining the concept where it works on a digital device, explaining to pupils that Scratch has a limited number of possible conditions to choose from. Let us summarise what we have learnt. A condition is a state we can check to see if it is true or false. Conditions start with an if. After a condition is checked, there are two possible pathways, true or false. Conditions are only checked when reached in the flow of control. Both pathways can lead to actions. My thanks to the Everyday Computing team who have published a great repetition and selection trajectory that I've definitely learnt from. Do go and look at their research. My thanks also to the others mentioned here for their research and support. As always, all misconceptions and errors are my own. Do get in touch if you have any questions. In Highest Hampshire Inspectors provide resources in all areas of curriculum that you can find on our Moodle. You're welcome to subscribe if you are in or outside of Hampshire. Thanks for listening.